So my name is Anjelica Gonzalez, and I'm a professor of biomedical engineering here at Yale. And I'm honored to be able to share some of the ideas I have in the seminar called Human-Centered Design of Biotechnology. And the idea behind this seminar is really to share with you that anybody can be a designer, anybody can be an engineer, anybody can be a scientist. We just have to understand who we're designing for in order to do that effectively. And so we opened the class with this idea that human-centered design, specifically in biomedical research, is a novel concept. It's something that people have done in Apple in designing computers and designing the iPhone, but really haven't taken into the scientific space when it comes to how humans are going to interact with biomedical technology. And so we explore how human-centered design and the concepts behind it might be useful for designing biotechnology. And we focus on one method specifically called design thinking. Now, design thinking is a lot of fun and can be translated into a lot of different applications because it walks you through the idea that if you first empathize with the person that you're designing for, you can come to understand what the real problem is. A lot of the times as scientists and engineers, we design for what we think the problem is or what we think the problem should be for that person. But really, if we come to understand what the context of the person's life is, their culture, their medical issues, the way they understand their issues and their environment, we could probably design technologies quite more effectively. And it really gets into defining the problem in a really accurate way. So if we can define the problem, then we can probably figure out a million solutions for that one problem. And that's what ideating or brainstorming looks like. But really, the whole goal of this project, of this design thinking methodology, is to get to rapid prototyping. Because too much of technology design and science is really in the thinking phase. We get so hung up on why things are going to fail that we often don't move to just building something out. And so we focus quite a bit on prototyping and what it means to do a rapid prototype, a lean prototype, a fat prototype, and how we can really get things into the real world and out of our heads. And finally, we think a lot about testing, why we want to test, who we're testing these devices and ideas with, and the kind of feedback that we want to get. And so that concept of design thinking, again, is something that is very useful in getting technology in the classroom, getting students to really get their hands dirty and start to understand how to design different technologies, whether they're biotechnologies or environmentally based technologies. But it really gets students engaged and off the ground. And so in this seminar, we do design thinking right off the bat. One of our, I see Carol Boynton, who's in the seminar that we had here in New Haven. And really, the goal was to get everybody engaged right off the bat and do some design thinking. Now, the focus of this is to use design thinking to answer a couple of questions and to explore the innovation space. So we think about what is innovation generally and how is that applied to the biotechnology developments that we use in our everyday lives. So those technologies could be as innovative and as complex as vaccines, or as simple as a toothbrush. We all use them every day and they have to be designed appropriately so that somebody will want to use it. And so we have to think about who our innovators are. Are they always scientists at Yale and Harvard, or can they be students in our classrooms? Can they be my twin 10-year-old kids who are designing things in their bedrooms every day? And we want to think about what makes an innovation a success. And really that doesn't mean, did I build this and did it work? But it really means, was it available to the people for whom I designed it? Was it affordable for the people for whom I designed it and sustainable in the environment and the context in which they live? Or was water not available to help this thing get clean and sterilized, so it's just trash? Was it accessible? Were there markets and were there supply and manufacturing chains available for this technology to get to the people that we were aiming for it to be used for? And finally, do they want this technology? Do people really want the technology that I think they want? And until we design appropriately, thinking and taking into account all of these considerations, availability, affordability, accessibility, and adoptability, then we're just designing for ourselves and not for the world. And so these topics that we explore in the seminar, including what is innovation, how we create innovation. We talk a lot about health and medical technologies that are already out in the world, how they came to be. We talk about the cost of making technologies. We talk about culture, ethics, and ethical considerations in making technology and making it available to a group of people, or making it specifically for a group of people. But we also talk about the metrics. How do you know what the prevalence of a disease is? How do you know what the incidence of a disease or disorder is? How do you know what the cost associated with that disease is? So we do a lot of math. So what that means is that this course is appropriate for people who are interested in some math, some chemistry, some bio, or teaching anything in that space, and at all levels. Because Carol Boynton, again, was a kindergarten teacher, and she took this into her classroom. But we've had people teaching pre-calc, calculus, and high school math and science take this into their classrooms as well. So I think it can be applied, these concepts can be applied to a broad range. So as you can tell, I'm very excited to take part in this seminar, and eager and happy to answer any questions you might have.